Jai Hind viewers, we welcome you back to another session from our forum. We have rebranded ourselves from MRO Digest forums to MRO Channel Forum, and this recording is now coming to you from MRO Channel Forum. We are talking about Indian vehicle technology today, and we have got two very eminent personalities who are going to be telling you about what they think can be done in this very important sector. We have with us Lieutenant General Dr. N.B. Singh, who served as the Director General of Corps of Electronics and Mechanical Engineers and Director General Information Systems, and was a founding member of the Armed Forces Tribunal Jabalpur. He specializes in armored fighting vehicles. A knowledge leader, he made significant contribution to the development of Takshak vehicle, Arjun ARRV, and Dhanush. He was military attaché technical at the Indian Embassy in Moscow. He writes on issues related to strategic readiness, defense industrial base, self-reliance, and data analytics related to MRO. We also have with us Lieutenant General Director General Electronics and Mechanical Engineers and Director General Information Systems. A chartered engineer, he was awarded the Eminent Engineer Award 2020 by the Institution of Engineers. He is a professor of practice at IIT Tirupati and also a board member in their innovation hub. He writes and speaks on emerging technologies like C7, ISR, and AI in many publications and platforms. General NB, sir, if I may, the first question to you, sir. How do you feel that how is the Indian auto sector placed for tech readiness to take a prominent position in the evolving landscape in the automobile sector? General NB, sir.
Yeah, thank you, Justej. You see, in India for the past, I think, 4 decades, we have been witness to this so-called automobile transformation. You'll recollect what was the state of the auto industry in the late 70s when there were just two to three players in the market, and how from the early 80s the transformation took place. And today we have reached a stage where we are the largest manufacturer of tractors. We are the second largest manufacturers of bus and the third largest manufacturer of heavy trucks. So that is where we have reached. The total market size is about $200 billion US. Out of that, $25 billion is export of auto components. This industry amounts to about 7% of the GDP and employs more than 4 crore people. So this is where we have reached today. And if you look back, we will see that this achievement has been driven primarily by the two auto majors who came into this country very early, namely Maruti and Hyundai. And thereafter, of course, our own local industry also geared up and picked up some market share. So what I'm trying to say is that this growth has been essentially driven on a build to print kind of a technology, where things were done outside. At least the major designs were done outside, brought in here, localized for local conditions, and then the manufacture started. Now, trends, if you look at the future trends which are there in the automobile industry and the market, people say that yes, India is an emerging market. Why? Because of the burgeoning middle class, because of its uh, young population, and of course the experiences of the world with respect to dependence on a single supply chain. So all these are being talked about, and therefore one is very uh, at least everybody is very hopeful that uh, the coming years for the automobile sector will be uh, full of a lot of activity. Uh, but if we want to be a major player, a prominent player in this evolving landscape, then we have to first understand this landscape as to how it will pan out, and then be prepared for it. Because I think the way we have evolved in the IC, the internal combustion engine led automotive revolution, uh, that may not work here if you really want to capture a big size of the emerging market. uh, so first of all, some of the trends which are being talked about, first of all, of course, is all electric. Everyone wants to go electric because of the environmental concerns. uh, there is a focus on autonomous driving everywhere. uh, most countries are very gaga about it. I have my own reservations with respect to the Indian context. But anyway, that's an area, a technology, where at least we can play a significant part as far as developing subsystems and all is concerned. Uh, then, of course, is IoT, which we are witness to it in most of our passenger vehicles. Things like mobile connectivity, car infotainment systems, vehicle to vehicle communication and navigation and things like that. Then another big thing which is now coming up is shared mobility, which has actually changed the whole concept of ownership of cars. Sustainability, of course, is the new requirement which has come in primarily because of the environmental concerns. Uh, and apart from this, you have the rise in fuel cell EVs, because that is one area where there is a lot of work going on. And the hope is that since these are non-polluting, ultimately one day, maybe a decade, 2 decades later, the whole world will possibly switch over to this technology. So if you look at all this, the potential is very, very large. Uh, it is said that the expected market for the EVs is around 13 to 1500 billion dollars. The Indian market itself is expected to rise up to about 55 billion dollars. That is about 50,000 crores. And today we are about around 1 million. We have touched the 10 lakh figure for the EVs. So that's a very, very heartening thing. Now, with all this background, if we talk of the technological readiness or the technical readiness of the Indian automotive industry to play a prominent role in the evolving landscape, uh, I think a certain amount of uh, long-term planning is required. Some of it is being done by the government, but a lot has to be done by the industry itself. Uh, to be able to position the Indian automotive industry in a formidable uh, manner, both in the Indian as well as their global market, the important thing is, that we should not repeat the practices of the past, where essentially uh, we first started off with the assembly of semi knocked down or completely knocked down kits, and then gradually went up to indigenize those parts which the OEM was willing to indigenize in India. And I remember for good about 20, 25 years, at least in the Maruti, there was a talk that, the transmission still comes from the OEM, and it's not being manufactured here. Anyway, a lot of things have changed. But with respect to the EV, in the EV domain, one thing heartening is that there are hardly just about 20, in place of 20,000, 25, 20, 2,000, 2,500 odd components and aggregates which are there in a classical IC engine driven vehicle. Here the numbers are just about 20 plus. So, things like the battery pack, things like the hybrid electric drive, things like your traction motors, your DC to DC converters, your generators, then electronic controls, electronic control unit. These are all, things which are there in an electric vehicle. And thrust should be to get into the design and development, to acquire this capability of designing and developing, because it is the numbers, the number of aggregates and components are so less that, unlike what has been practiced all over in the world, of outsourcing most of the supplies and keeping a few critical ones with them, here I think we have to follow the example which has been set forth by Tesla, which means that both upstream and downstream integration we should be doing here. Because once we are able to do that, then we'll be in a position to innovate in the stride based on the requirements of customers, based on the requirements of technology and cost. And that's the way you will be able to have a full control on the costing of the vehicle, because you have to understand that being in this era of globalization, there'll be a lot of players, experienced players from outside, who will be also joining and coming and trying to find a place in this market. So as far as technical readiness is concerned, I feel that some amount of planning has to be done, both at the government level and at the industry level, to see that the entire supply chain is indigenous, because then only you will be able to get a sizable chunk in this market within the country as well as outside. So that's the initial comments I wanted to put across.
Thank you very much, sir, that you have covered a large area and touched many very, very important points, both historical and contemporary, and looking forward also. So, generally, the first question to you is that what are the technology trends that are redefining vehicle technology in India, and generally speaking? Anil Kapoor, please.
Thank you very much. Actually, if we look at the whole technology landscape, there's a huge amount of convergence we find today. I mean, when all of us did our engineering, mechanical was a pillar which was quite distinct from electrical and electronics. And while electrical was maybe a common denominator, hardcore electronics and hardcore mechanical remained two distant pillars. But I think that distance today has faded. There's a huge osmosis. And when we look at a technology perspective, I think the vehicle technology today is very much electronics. And the future trends, which have already started appearing in the horizon, show that vehicle is no longer a mechanical, should I say, piece of equipment. Actually, it is a electronics and a technology flotilla with a lot of sensors, a lot of software, and a lot of environment. Let me qualify this further. Today, when we look at the digital transformation, it's all about, which I often say, 4Ds: data, digitization, digitalization, and disruption. And if I were to design think this issue today, I mean, because design thinking is a trend which is very important, which, while it is very visible when we speak of Airbnb, Facebooks, Amazons, Netflix, and others, Let's look at it from a vehicle technology perspective. The trends have been that driving ecosystem, which involves the driver per se, in a driver cabin, if I may say, or in a car. And when we look at the environment around him, that means the road or a cross-country environment, the requirement is to give him so much of him or her, so much of comfort in driving that it is fairly safe. And if he decides to go from place A to place B, he has geospatial data available to him to be able to reach there, uh, even if he were blindfolded, may I say that. And therefore, with this as a backdrop, I'd like to touch upon some technology trends which are really digital transformation happening. The first is that smart sensors have come in a very big way today. And today, the current generation cars have anything from 80 to 150 of these sensors. The high-end Mercs, if you look at, today, you can just put it on auto parking, and if the space is just enough for the Merc to fit into that kind of a place, in less than a minute, the whole system actually parks it there, no matter wherever you kept the car. So that is the kind of trend that we see with smart sensors. And then all these smart sensors are actually put together in an electronic control unit, which is an interface unit. And you have a large number of ECUs, which are zone based in a vehicle today. And then, so that is the next big trend, that when you look at a sensor and you look at an ECU, it is, I think, a combination which is there. And all of them are embedded into a central processing unit, or we can call it an onboard computer. And therefore, this by itself is changing the landscape of driving and maintenance. And now let me move a step ahead. Now, when such a vehicle, actually, you look at such a vehicle, what becomes very predominant is a dashboard based on big data analytics. And therefore, both for the driver and the maintenance agency, they are tagged in a manner that whatever is happening in the vehicle gives the driver a huge amount of driving comfort and gives the maintenance agency huge amount of visibility into the reliability of the vehicle. So this is the new trend which we are seeing, all manifested through technology. And therefore, what we've been all our lives practicing of in terms of periodic and preventive maintenance is actually getting into the space of predictive and prescriptive maintenance, which we always thought it should be. So I think from a design thinking perspective, this is what technology is bringing on the table. Let's look at it in another way. Now, when we look at digitization and digitalization and these technologies today, there is a vehicle to vehicle talking. So as these vehicles proceed on the road, we may not know, but two vehicles are talking to each other. So there's a vehicle to vehicle, vehicle to infrastructure, vehicle to network, vehicle to platform, vehicle to pedestal, because all our mobiles are also unobtrusively talking to these things. And therefore, the next trend that we find is that communication is becoming a big, big part of vehicle technology. And within the vehicle, we've got wired protocols and wireless protocols, which are based on Bluetooth, but external, it is based on Wi-Fi protocols. And this Wi-Fi protocol is making a huge difference today. We all have heard about ADAS and so many other systems which are very prevalent in the vehicle today, which gives a lot of freedom to a driver that if he were too close, the vehicle by itself in an autonomous mode will take control to make sure that there is no accident. And therefore, this is the kind of comprehensive connectivity that is being visualized internally in the vehicle as one trend and external to the vehicle as another trend. So this is the new normal which we are looking at. And therefore, this takes me to the third important thing, which I call digital vehicle engineering. I mean, all of us who've done vehicle engineering or auto engineering today, there is a new subject in terms of digital auto engineering. And while I've touched upon something within the vehicle, let's look at industrial infrastructure. Today, a vehicle industry is actually transcending from industrial automation, which it did till now, into industrial autonomy. Again, all based on smart sensors, IoT, big data analytics, and AI. So you got minimum kind of a human interface and the kind of productivity, the kind of quality control, the kind of supply chain management windows that get created in a very proactive manner actually are changing the way things are happening. I mean, today we all know Toyota is facing a huge challenge. Their high cross, the waiting time is almost 1.5 years. Something that we heard, maybe some time back when Bajaj started their Chetak, which was an export model, and if you wanted it in India, you had to wait for some time. I think that is the kind of problem because the whole system is now based on semiconductor and software on which they have limited control because the semiconductor manufacturing is happening in one place, Taiwan, and perhaps there's a huge, huge queue there. So, really speaking, we are seeing these trends happening right in front of us, where the waiting times have become huge because of this. And if I were to take this a step ahead, when I look at the industrial environment that I alluded to, today everything is available into a computer-aided design, computer-aided engineering, and computer-aided manufacturing. We've all been talking about it, but now it is from automation to autonomous mode. It happens in autonomy. There are robots and robo arms and robo welding, and everything is happening in a very automated manner. And the other big thing that is happening is smart manufacturing, smart additive manufacturing, and 3D printing. And therefore, the trends are that you need not hold much in terms of space because you could do just in time through 3D printing. And this is the kind of new trend that again we are seeing. And so these are some trends when we look at it from a industry and a vehicle perspective. If we come to the user environment where you and me are involved, actually there is a huge amount of change in consumer behavior today because social media and so many other things have come where most of these trends are being thrown in. They're being thrown in. I mean, today servicing agencies are actually getting into social media and changing the way maintenance was ever done. So this is the new trend as we find, all driven by technology. So really speaking, it is sensors, it is software, it is big data analytics, it is artificial intelligence, it is onboard computer, it is nano and advanced materials, it is robotics and robo welding, and if I may say, smart additive manufacturing. So this is getting the new landscape as we look at it in the complete ecosystem, because today it's not vehicle in isolation, it's not even industry in isolation, it is a full womb to tomb journey that is being enabled through this technology. And therefore, one very big trend that we are finding in vehicles which are based on software is that today the way we get software updates on our mobile, there are a lot of software updates that are coming in these cars. And moment you switch on, you have to really make sure that your software is well updated. And therefore, cybertronics, which is cyber and electronics warfare, is becoming very important. And this gets me to my last point, which I want to bring out. The Automotive Research Authority of India, ARAI. It's a huge, huge challenge for them because they have to now set new standards, new ISO standards for management of this change which is happening. Because no longer will the old standards and trends do. There are some digital trends, but I think they have to look at 10 years ahead and start getting into revamping a unified system of all the ISO standards to look at the complete spectrum from EVs to hybrids using these technologies. Thank you.
Thank you very much, Anil. You have brought in us so that it's become quite clear from what you said, and you have been talking about it earlier also, that the amount of new technology which has come into vehicles and in fact now become vehicle technology itself is huge. And so, General NB said, that brings me to the question that with all these new types of technology coming into the vehicle, new opportunities are also going to be there. So, and we have seen so many of the MNC automobile companies are setting up R&D facilities here in India also, maybe to have our top-notch human resource. So concerning this only, concerning the research and development and industrial capability, General NB sir, available in the automobile sector, how do you think it can make a positive impact on the defense self-reliance initiative of our government. NB, sir?
Yeah. See, already the benefit of the technologies which are available in the civilian sector, primarily they came in through the passenger car route and to some extent through the heavy trucks route. They are visible within the armed forces because as far as light vehicles are concerned, a number of these light vehicles which are operating in the civilian domain have been picked up by the military and is being used. Similarly, in the domain of GS vehicles also, we find that yes, something similar to, of course, a stripped down version of the civilian models in a different kind of a configuration are entering into service within the military. And therefore, yes, certainly the development which has taken place in the automotive industry field has to some extent been passed over, especially when we compare, the condition of the vehicles in which we grew up, like the Jonga and the Nissan and the Shaktiman and all, and compare it to the current lot of, and of course the good old Ambassador. So if you compare that with the current generation of vehicles which are there within the military, you can see the difference. But apart from that, what I will comment is that most of these, therefore, were efforts by the industry to cut and paste the technologies and the systems which are available in the civilian domain and offer it in some form or the other to the military. Hardcore R&D to develop, mission-oriented vehicles for the army, these efforts did not take place, and some of them were very, small ones, some small initiatives here and there which were taken. And as a result of which, in the field of high mobility vehicles, in the field of all-terrain vehicles, there is a distinct void. And that is, that surfaces off and on. So all this capability gaps have been created primarily because our automotive industry, which was quite capable, did not invest in military vehicle related technologies. And now that there is so much of focus, so much of thrust on self-reliance, I think the existing infrastructure which is available with them, as well as with the testing agencies, for example, ARAI or the ICAT, together these can be employed to carry out R&D activities primarily for the high mobility and the all-terrain vehicle sectors. And there is a distinct void here. If you look at it, there is a void in almost everything. You start off from the basic mechanical systems, you start off with the engine, you start off with the transmission, you start off with all the other auxiliary systems for the engine, like your cooling system, your ventilation, air conditioning systems. All this, there is a void. You come forward and look at the drives, whether it's a cross drive or a longitudinal drive, again, there is a void with respect to, automatic transmissions. There's a void in the suspensions, whether it is classical mechanical suspensions or the hydropneumatic suspension. So what I'm saying is that the complete mechanical powertrain, there is independent suspensions, there is a complete void here. Then you get onto auxiliary systems like your NBC system, firefighting systems, etc. Again, you find that whatever is being done here is based on some kind of a technology transfer from outside. Yes, you can possibly, pick up things in the IoT domain and transfer it here. I feel some of that can be used in our context, particularly, things like navigation system or keeping a track of the convoy movements, your tire monitoring systems, and condition-based monitoring systems and all that. These, as far as the electronics and digital technologies are concerned, possibly from the private applications, these can be picked up and applied here on a need basis. There are some technologies like ADAS and lane driving and auto parking and all that, which have been given by the car industry, essentially just to remain a little ahead of the primary competitor. I feel these have these technologies, while they may be useful as far as self-driving vehicles are concerned, in our context, where people don't even maintain the minimum mandatory distances between two vehicles, these can lead to huge amount of accidents also. And therefore, in fact, some people advise that when you move on highways and all, it is better to switch off your ADAS, especially in in India. So those technologies, of course, I don't think there'll be a requirement for that in the high mobility vehicles, which are required in the army. But hardcore automobile components and aggregates, yes, the existing R&D which is available, I think they need to now divert attention towards this and see that we have indigenous, subsystems available, so that the next generation of high mobility vehicles, which of course are not only load carriers but are also platform carriers. Most of our platforms are also built ground up from there. So there, if their energies can be channelized and we start developing these kind of subsystems, then we can really offer some very good solutions, not only for the Indian military, but also remember that there is a huge potential for low cost, high performance vehicles in most parts of the world, and that is a market which is awaiting to be tapped. So if we can use whatever industrial infrastructure, whatever technical infrastructure, R&D infrastructure we have created in filling up this capability gap, I think we will be able to possibly in the years ahead truly become self-reliant in at least all kind of light GS and high mobility vehicles. And there, of course, the next step will be to go in for track platforms and wheel platforms, where again the technologies are same, only the power requirements and the scale at which they are to be made, that differs. So overall, I think the Indian industry has that capability. Only thing is that you need to, support them.
Thank you, sir. Thank you very much for bringing out the possibilities which are there. And of course, these possibilities also convert to challenges. And if we are able to somehow meet those challenges, opportunities are bound to be there, even more than what they are today. So, Anil, the next question is to you. What are the challenges and opportunities in vehicle technology as you look into the future? Anil, please.
Firstly, General NB is alluded to if I may use the basic assemblies and sub-assemblies which remain a challenge and elude us. So to my mind, the first big challenge is getting our mindset right. And why I say so is we are very much into an import-oriented yesterday syndrome. With the result, you do not want to take chances on the research and development that is associated with it. I think the first good thing that has happened is that a negative list has come up from the government of India. But I don't know how religiously we're going to follow it. And more importantly, we have to look at it as a program approach like the IGMDP, where we actually program ourselves of bringing the right people on board, like we have in our own core of EME maintainability advisory groups, MAGs. I think we need to get design and development advisory groups, especially when we look at military equipment and such like things, because we have huge amount of cerebral human capital which can actually aid and create wonders in this, like what Angel and we brought out, that all these areas are actually open and begging for R&D. So I think the first challenge is that whether it is DRDO or a private sector or public sector, I think first is we need to have a program for managing these value adds in terms of the mechanical assemblies and systems. The second challenge is managing legacy. We have almost 60 odd percent, if not more, of equipment which is actually legacy. And whether we look at a mechanical system or electronics, but since we are talking vehicle technology, let's look at mechanical systems. And therefore, I think that is the second big challenge. And in both these lies a huge, huge opportunity. Today, we're going to be a 5 trillion economy shortly. There is a huge furor on manufacturing. There's a huge furor on research and development. There's a huge furor on technology and innovation. And I'm aware because I'm in a hub where we every month we are having board meetings to see how technology is moving. But the fact is, all these are happening without a program, without a project. Now, since we are transcending into a lot of big data analytics, a lot of software, a lot of cloud, I think we need to get a handle over data privacy, data protection on our cybertronics. So that's again a challenge and an opportunity. I'm happy that we're now into 5G, and very soon we've already started talking about 6G. I think these will be the need of the hour in future, because when we are looking at machine to machine kind of communication and the amount of data transfer that has to happen, I think we cannot do without these technologies. So when we look at the complete EV space from a technology perspective, these are the challenges. Now let me pull out some more points. One is EV and hybrids are coming up, and today you have renewable fuels coming up. While EV poses new challenges in terms of batteries, I mean, where are the cells getting made? Again, that's a singular place which is getting done in China. And unless we create that cell, which is the basic thing, uh, battery manufacturing is all contingent upon that little cell that gets generated. So I think that's a big challenge and a big opportunity again, where we need to get it to the cell level. And I think high time that we have a program on these as well, because this is where the future will lie. Clean hydrogen and other such renewable fuels, fuel cell, General NB alluded to. I think these are the other areas where we can look at the complete new transition happening into both the passenger vehicle space and the load carrier space, including buses, and falling apart. So as we are graduating into this, these are some of the areas which are huge, huge challenges. And I think, to my mind, we need some very well thought through programs and regulatory mechanisms. Time has come to think through this in terms of regulation, in terms of programs, and getting the right people on board to actually move about this complete vehicle technology space, from the mechanical right through to electronic software and emerging technologies. That, I think, will be a holistic way of managing challenges and opportunities. Without that, band-aids will not work. This is not a band-aid zone. This is a zone which is very, very different and very relational. Like I said, EV is related to your production of electricity. I mean, you cannot just divorce the two. They are very much wedded, and you have to look at an area where you don't run into a divorce over a period of time. So that is also equally important. So these were some thoughts which came to mind. I thought I'll just share.
Yeah, thank you, Anil. Thank you. You covered a lot of ground there. So, General LV sir, now coming back to you, a little bit look into the future. So, what is the road ahead for the auto sector to seize the opportunities unfolding in the coming decades? General LV sir?
Yeah, as I had mentioned, in the initial remarks, I had given you the size of the likely market, both within the country and outside. And to that, I'll add, the initiatives which has been taken by the government, where the government has at least targeted that by 2030, 30% of the vehicle fleet should be EV, and by about 2060 or so, even the trucks and the bus category also will go electric. So these are the targets which have been set by the government, and therefore they give you an idea of how the market in India is opening up. If today we look at the kind of vehicles, the amount of vehicles being made around in the region of 2.3 to 2.5 crores, all inclusive two-wheelers, three-wheelers, and all that. That is the size of the market. And such a market cannot be sustained through import of, components and cells and things like that. So, taking into account this huge opportunity which is available, I think it is very important that adequate R&D facilities are created to see that the entire auto, as I said, especially with respect to EV, because one is hoping that ultimately, whether it is battery powered electric vehicles or fuel cell powered electric vehicles, finally, it will be all electric, which will be required from the environmental, targets which they have fixed of bring down the global warming temperatures and all that. So if we have to move towards an all-electric regime, then it is important that a lot of efforts are put into this sector of cells, battery packs, your traction motors, the generators, the DC to DC converters, and the assorted electronic modules and subsystems which are patched onto it. So all these are areas where we need to put in money, carry out R&D, and have our own local brands ready, not only for consumption within the country, but also outside, because there are some individual cases where MSMEs are making, final drives or traction motors for people outside, but that should now be in very massive and large numbers. We have to look at establishing enough capacity for manufacture of low-cost steel, because that also is, some efforts have been put in. But yes, overall, we should become self-sufficient in that. Indigenous supply chain I have mentioned. Then military vehicle technology, how the EV technology can be applied there. To me, I feel that our complete requirements of combat systems in the Himalayas will benefit enormously if we move into hybrid electric drives, because they offer a great potential. Only thing is, we will have to do some amount of local innovation to see that the capacity of the cells, which drastically reduces in cold temperatures, how we are able to preserve it. And so there are a lot of options available, but I feel that both from the performance and survivability angle, hybrid electric drives or diesel electric drives are the answer for making customized weapon systems for the LAC. No other country will give you this design. We only have to create it, and we all have to experiment it till we achieve system maturity. And I will mention here that today the situation in India is similar to what was there in Europe and America post World War II. Rising income levels, enough affluence there to pick up vehicles and discard them in 3 to 5 years, population increasing and things like that. So all that, what happened in Europe and which was responsible for this huge amount of, I'll say, growth, in the passenger vehicle segment, the condition in India is similar. You have a burgeoning a growing middle class, you have a young population, you also have that materialistic culture coming in of use a vehicle for 3 to 5 years and then going for a change and things like that. So we have those conditions here. So we really can create another revolution in the field of EVs and fuel cell powered vehicles. Only caution here will be that we should not get into that same tradition of overconsumption, because I think that much of sense now has come in everyone that we need to preserve this planet for the successive generations. So possibly uh, this whole growth within the country will take place in a little calibrated manner. At least that is my hope. Uh, the concerns are a number of them, because as the number of vehicles are increasing and with the scrapping policy in place, we need to find a method to dispose of. We need to have a disposal policy where we should see that each and every part of these scrapped vehicles is picked up and recycled in whatever manner it is possible. Then second is, of course, this policy is in place, but the importance of implementing it is very important. Today, it's very common to see in most cities polluting vehicles. You can just observe it and say that, yes, this is a vehicle which is polluting the environment, but is running freely on the road. So those kind of, checks and balances have to now come in. The concerned people have to be sensitized. And if not, then, strict penalties have to be imposed so that these vehicles do not ply on the road. Then, of course, alongside this proliferation of vehicles, we have to look at parking places, because that is becoming a problem, and traffic management. We have to put a focus here and see how it can be managed, because it is chaotic. I mean, you go outside any airport, you go outside any railway station, and the chaos which you see there. What will happen if 2.3, 2.5 crore vehicles keep getting added every year? Then ultimately it's going to choke the whole system at some point of time. The next concern is, of course, the driving discipline, because this again is very, very important. And this is where I feel that the self-driving vehicles, the whatever algorithm you make there, it may not be strong enough to see to sense the kind of driving which is done here in India. So it's important that this aspect of driving discipline is taught to our people. And next, of course, is the increased incidence of, because with good roads now the speeds have gone up, so the incidence of accidents has also increased, the number of fatalities are increasing, and all this will remain. It's not going to change. So therefore, there has to be a very, very foolproof system of CASEVAC, so that casualties can be evacuated if required, through ambulances placed at various places or through helicopters, so that lives can be saved. So all in all, there is a requirement of while on one side we may look at making the best use of all these growth opportunities and trying to become the number 3, a $5 trillion economy and things like that. One has to also look at it from the social responsibility angle and see that alongside this, the youth of this country is equipped with driving habits and attitudes to face this kind of growth in the automotive densities on the road. And finally, of course, I will wrap up by saying that there is no alternative for the world except to go green. Now, one of the methods which have been shown is to see that the IC engines get replaced by EV. People have brought out the flip and flop side of EVs, but I feel that ultimately going green with green electricity and green hydrogen is the only way forward. And if we can do this, then possibly we'll be able to meet the goals of, reverting back or scaling back the rise in global temperatures to within 1.5 degrees of what it was before the industrial era started and the global warming occurred. So with that, I like to now end on the note that yes, the automotive sector within the country is poised for the second revolution. It will be the first genuine one for us, because the first one, as I said, was essentially built to print. But now is the opportunity where we can design, develop, and possibly offer it to other countries on the same build and print mode. So that opportunity is there, and I'm sure that this huge the young lot of engineers and technicians who we have will be in a position to seize this opportunity and make the best of it, both for the country and for themselves. So that's all. Thank you.
Thank you very much, sir, for sharing your wisdom. And there's so many points over there which will be of use to anybody who's listening. And now, of course, that brings me to the final question to General Kapoor, and that is that on similar lines, I'm looking at you. That what do you feel is the likely technology escalation landscape in vehicle technology? General Kapoor, please.
So, given the trajectory of technology, the way it is galloping today, I think there's a huge amount of, if I may say, opportunity which awaits the future vehicle technology. Let me start with unmanned vehicles. I think the first big opportunity is driverless cars, as we say, and as we speak, we all are aware that in California, the Ubers are driverless. They already, in most San Francisco and others, they've already started operating in a big way, driverless cars. So I think the first major trend is we're going to have driverless cars. And what I said earlier, when we have driverless cars, we'll need to build in a lot of autonomy, right from driving to parking. And therefore, that's one very big opportunity or one very big trend, which sooner than later will come globally. While we all know that we have a huge, there are some countries which are not as blessed as us because we have a demographic dividend in terms of a youth bulge, and therefore we'll never run out of drivers, and that's a reality, and that's for sure one very good thing. But I think unmanned vehicles will take trends, if not in the CV street, definitely in the defense. Because nobody would like to lose trained troops when you have an unmanned system for wrecking force, if I may say. So really, it is one beautiful trend, and I think we should embrace this trend by bringing in a lot of technology to do this and make it happen. The second trend, which I again find happening with Volkswagen in Germany, will happen in India, is design your own car. So really speaking, you sit on a kiosk and it's all drop-down menus and you design your car, and at the end it tells you, okay, please be prepared to pay 25,000 euros. And then you say, my God, my budget was only 20,000 euros. So then they'll tell you, given your taste, which they've read through the choices that you made, and there's a huge amount of generative AI and data analytics that has gone into it, they'll remove some of the desirable things and keep the vitals and essentials to tell you, then your car could look like this. And moment you said yes, they give you a docket number and they give you a date and time by which your vehicle will be ready. And they give you a full schedule, which is a kind of a minute-to-minute schedule as to where will your vehicle be at what point in time. So I mean, I'm calling it minute to minute, but it is based on some very relevant milestones. And if they told you you could come at 18:32 tomorrow in the evening, your car would be waiting for you at 18:32, duly ready. So that is the kind of, and that's one great example of industrial automation to industrial autonomy, where the whole system from design through till the development is controlled by them. And then, of course, the life cycle sustenance support. If this is what IA to IA is doing to them, you can imagine the life cycle sustainment support, how intimate it gets and how easy it becomes. So that is the second big trend, I think, sooner than later. Hyundais and Kias and Toyotas and our own Tatas, Mahindras, they'll have to embrace this. I mean, there will be a nudge in this in the future, so they better get prepared for designing your car. If they're not, they'll be out of trend very soon. The third thing I find is that with EVs coming in, I think, in all areas where there's drought, we look at uh, rainwater harvesting. I think we have to look at solar harvesting in a very big way, because that's something that is available 24/7 globally, and I mean, at least for 8 to 10 hours in every country. And if we can develop systems for solar harvesting through infrastructure, that means we have buildings where you can harvest. There are materials today which you can put in the building materials to harvest solar power. Today, there are roads which are getting charged by solar, and it's happening in Utah in America. There's a Utah University who've done a trial on this, and they are running EVs on this, where while the vehicle is running through induction, they are charging the vehicle. Of course, is it very efficient? Not for the moment, but I think trends are it will be with time. It's a good beginning. Similarly, the canopy of the car is all such that it absorbs solar power. And of course, the efficiencies today are low, but with time, this will. So this is the next big trend. The third technology is regenerative technology. We've had regenerative brakes. We've had, turbocharging has been a very big trend in regenerative. So we're looking at clutches, we're looking at regenerative clutch, regenerative. And while these may be trickle, imagine when you have X crore vehicles flying. Look at the cumulative effect of this. I mean, so I'm not really looking at per capita, but I'm looking at the cumulative effect of all this when it is thrown into the system. And therefore, that is very important. Now, recently, I was part of a seminar, which was an Indo-US seminar, and we had one very interesting concept of intelligent adaptive chassis. There's an Indian startup in the US who's come up with a concept of intelligent adaptive chassis. So what is intelligent in this is that right from 3 ton to a 25 ton, they've defined different wheel bases. And the chassis is quite flexy. It's all a composite chassis. They don't use steel. They use composite materials because it is lightweight and has the requisite strength which otherwise you get from this thing. Though, there are greenhouse GHG effects and all. We have to look at those things, but it can well be done in steel. So, but that is not important. What is important is that it has beautiful, intelligent vehicle management system where it has those connectors which will connect up. So it's all embedded in the chassis. Your complete EV will be in the chassis. Your drives will be in there. Your powertrain will be in there. Your EV bank will be there. And why do they call it intelligent is that you have 2 banks. One is an EV bank and one is the hybrid partner. So hybrid partner could be clean hydrogen, it could be CNG, it could be anything. And therefore, they've made the whole system in a manner that it could be a buddy pair kind of a system, everything in the chassis. And now the whole vehicle is designed around it. And it's catching a lot of traction in the US. I'm sure whosoever attended this seminar in India, and we had some of these big transport guys who were there, they were thoroughly impressed with this technology because they felt this is where the future lies when we look at hybrids. Because this is the next trend of intelligence getting into chassis and giving you a very safe corridor. So really speaking, chassis by itself is a very safe corridor to house your battery bank, because anywhere else it could, in case of an accident, it could have problems. So they've created those kind of safeties which are inherent in the system. So these are some of the trends. And of course, I've spoken of some in the initial part, which is comprising semiconductor software and all that. That will continue to enamel us and create the next gen ease of driving, ease of maintenance, and very informed decision making on the complete home to home journey. So that's one big trend which is in any case manifesting. And the last thing I'm looking at is, given the constraint of space that we have on roads. I mean, today We all are aware in NCR, you make a flyover within 15 days, you have traffic jams again manifesting, remanifesting. And despite the best of Google Maps, you find that all the possible places from A to B, all the possible routes that you could take are in red zone or orange zone. So really speaking, I think flying cars, which is unmanned autonomous systems, are going to be a norm. So you'll have a hybrid system. You can drive up to a point and then maybe either add attachments and then fly off from a helipad or something like that. So I think that would, again, if we are lucky, we will see these trends happening in front of us. I'm aware that in the innovation hubs, they are talking about it. They are into specifications of it. They're trying to design it that you carry a car up to a heliport, and at the heliport you take off and land another place, and then you close the system and drive into wherever you want to drive. So really, these are some interesting things that are going to be happening in the future. And I think the vehicle industry, by and large, and of course, quality of life will undergo a major change in times to come. And we're looking at all this with a lot of enthusiasm and interest. And thank you for this opportunity.
Thank you, in fact, to you for giving us these details. Now, viewers, we intend to keep bringing to you panelists like you've seen today, General N.B. Singh, Anil Kapoor, who are really having a rich experience and they are sharing their wisdom with you. We intend to bring you material which can be useful for you as viewers. So on behalf of our viewers and subscribers, I thank our panelists, General N.B. Singh and General Kapoor, for sharing their wisdom on this very important topic, which is full of potential. And with that, we bring this particular panel discussion to an end. Jai Hind.